Doing a hacker rank problem with a linked list of getting a node from um, X amount of spots from a position of a tail. So essentially, like, this is your linked list. What you want your algorithm to do is find like the 0th position index from the tail. So in this, since this is a tail and it's a 0th position, it'd just be the tail. So it'd be 6. If it's 2, so it'd be 0, 1, 2. So you return 3. So the high level kind of algorithm we're looking at is here. I made a comment. What we want to do is take this, well, the function is get node, and takes the head of the linked list and the position from the tail that you want to get that node's data. So the trick is you want to have a counter variable that you always check from this position variable, and once it's greater, when the counter is larger than the position tail, that means we found the node that we need. So just for an example, just say we have a linked list of 7, 3, 44, 10, and we want to find the node value one position away from the tail. What we do is we first we instantiate this counter variable. So we look at 7. While there's a head of a node, what we're going to do is end up traversing the whole linked list. So 7, there's then we want to change the head of the node to 3, and every time we iterate, we want to check to see if the counter is bigger than the position. So this is going to be fixed. So while 7, there's a 7, we move on to 3, but that means we change this to 1 because we increment it. Since there's a 3, then we move on to 44. What then we'll check is 1 greater than 1? No, it isn't, so we don't want to move the trailing node. Actually, we need to have a trailing node. Instantiate this to equals just the head, right? So right now it's still the head, since we looked at 7, we looked at 3, and 0 and 1 are bigger than the position. But then since we move on to the next 44, we increment this by 1, and since the counter is greater than the position, that means we want to make a trailing. We want to increment or call next on the very head of it. So trail node now would be head.next. Right? So then we move on and we increment this by 3. Then we move on to 10 here. And then the same thing, then we want to call next again. Pretty much that's what it does. And then we get to null, so then we don't do anything. So that means this number, we take the head, we call next, and next, which is 44, which is the same thing as going to the tail and going left 1. So, but yeah, that's kind of the little trick. My first naive thought was just to get the length of the list, so cycle through and just count up the length, and then from there you can take the length, subtract position, and then just call next that many times to get to there. So it would be 3, so it would be 1, or 0, 1, 2, 3, which you would get 44 as well, fit that way. But this only is log of n times. But then yeah, so the code then you instantiate your trail mode, which is the head, and your counter is 0. Well, there's a head, so well, you traverse the whole linked list. If the counter is bigger than your position that you're looking for, then you want move the trail node 1 to the right. If not, then you just call head next, and you increment the counter, and you just do that throughout the whole linked list, and then you return whatever your trail node is and its data. And if we submit this, yep, we got it. So yeah, kind of cool. So log of n, while loop, no recursion, anything. So